so it's okay. It just depends, but I'm waiting on the exact vaccines because of that.
He says he's like
I'll get it.
before, but actually in theory, it's good, it's not as bad.
Oh, good to know.
Yeah, so definitely do that. The Johnson & Johnson is the one that goes, and they say it's okay, and then everyone's okay with that, and Pfizer.
Yeah.
I've done that, and if they said they had to stop administering it out, because some of the nurses that got it, like, they had the rest of had to eat and want to go down.
I think I'll, if I can. I don't know what Johnson & Johnson's, I don't think it's effective.
I'm not even sure, I just know it's the one dose, you know.
Yeah, I think it's like in the
76 versus 90 plus.
Yeah, I'll stick with the 90 if I can, even if I do get that reaction.
All right. Posted 2 quizzes. These are hookworm general questions, hookworm life cycle. I set that due date on Wednesday. The next batch would be the GI tract nematode, so your ascaris, your camelinus, pinworms. We'll probably, if I can get those done, the life cycles questions are almost done. I have to get them up on the blackboard, but those will probably be due end of the week. So that way you can kind of prep for the exam. The exam will happen after Easter. So that was something I also did. Forgot about it. Forgot about Easter.
Because we have Good Friday off.
Yep. We are off on Good Friday, so even if I would have said we were going to have that exam on Friday, it wasn't going to happen. So yeah, we're off next week Friday. That means we will definitely have our exam that following week, and I think we did Wednesday, Thursday. That's probably what we're going to do. Again, just kind of judging on when we finish the acanthocephalins. If on Wednesday we know we don't finish the acanthocephalins, then I think we'll do Thursday, Friday for that exam. So that, because we'll finish up on Monday morning, and that'll give you all of what, basically the rest of Monday, Tuesday, Wednesday to kind of prep. Do have a lot of life cycles. There is a lot of information on it. Hopefully you're seeing that. So kind of these quizzes, and I can't believe it. I think I posted quiz 18. I've never done this many. But, all just kind of, when you get them and you review them, hopefully it makes these exams easier, and hopefully the final exam is less daunting. All right, so we're at nematodes, and we broke it up into 3 parts: the stichosome possessors, the GI tract parasites, and now these are the tissue dwellers. All right, so these tissue dwellers are going to be the parasites that live outside of the respiratory or the GI tract. All right, because if you live in the lungs, if you live anywhere in the GI tract, including in the mouth, it's going to be fairly easy to get your eggs out. All right, in the mouth, and we do have some nematodes that live up in the buccal cavity of different hosts. They release their eggs. Eggs are just going to pass right through, or you're going to cough them up. All right, if you're in the lungs, the ciliary action is going to carry the lungs up to the glottis, where you can either swallow or, again, cough them up. That's very easy. Once we get out of those locations, now the worms have this problem. And that problem is, how do I get my eggs out? How do I do that? Now, we talked about schistosoma, and we talked about strategy that those trematodes use. Strategies here are going to be a little bit different. All right? The solution for our nematodes here will really kind of depend on where we are in the host itself. All right, so you can have some worms that live just underneath the surface of the skin or close to the surface, behind the eye, so in the orbits of the eyes or in the nasal cavity. Our nasal cavity is kind of still in, you could say it's respiratory tract, but they are in the tissue of the nasal cavity. All right, that's our subsurface. So one of the ways in which you can get those eggs out is to just rupture the skin, and then your eggs can be released, your larval stages can get released. Or in some cases, you maybe, if you're behind the eye in the orbits, the worm itself comes towards the surface, comes out and around onto the surface where they deposit their larval stages. We do have eyeworms out there. All right, eyeworms that infect cattle, eyeworms that infect birds. I don't think we had. Do we have any pre-vet students from ag? Did you guys talk about bovine worms, eyeworms? I don't know. Some of your colleagues might have seen some growing up on ranches. All right, so you can kind of rupture the skin, come out to the surface, or you remain under the skin. You release your larval stages into that skin fluid, into that tissue fluid, and then you have typically a hematophagous insect come along, bite in that location, and pick up the larval stage. Basically consume the parasite along with the tissue fluid. All right, so you rupture the skin, or you remain in the skin and utilize now an insect host that has to come and bite in the location where the juveniles or larval stages have been released. That's in the surface. We also have nematodes that live deeper inside the body, deeper in tissues. Like, for example, heartworm, right? Our strategy could be one where the worm lives there for most of its life and then returns to the surface or to the skin just to deposit their eggs and larvae, and then when they do that, they basically die. It's thought that this was probably the ancestral pattern. This is probably the ancestral pattern, and then over time they've developed ways in which now the adult doesn't have to do this because they're releasing their larvae directly into the blood or tissue fluid, so that gets circulated, and then again, you rely on some sort of hematophagous insect to come along, bite you, feed on your blood and tissue fluid, and pick up that infective stage. All right, so we're seeing this transition where now we're looking at blood-feeding insects that come along, get infected, and then not only that, but then transmit to another individual. All right, so we're going to see some parasites that utilize these strategies. So the first one is Dracunculus medinensis. This is in the family Dracunculidae. All right, members of this family inhabit the tissues of reptiles, birds, and mammals. Now, Dracunculus medinensis is a human worm. It's a human parasite. It has the name of fiery serpent, has the name of Guinea worm, all right? And it's typically found in Africa, India, and the Middle East, or historically it's been found there. It's been termed the fiery serpent because it's been reported in antiquity. Right? We've known about it for a long time, and actually, this is probably how our medical symbol came about. All right, you've got a serpent on a stick. This is the rod of Asclepius. This is I think what historically people would say is the correct version. Right? Don't confuse it with the Calidaeus, I believe.
Hermes
No,
staff.
Caduceus. Yeah, Hermes staff, which is what? Something like that. Two serpents on a staff, typically with the wings. Now, you're going to probably see both. People use them as both to represent medical profession. But actually, this was traditionally the historically medical profession, and this is probably in reference to this parasite, Dracunculus medinensis, and we'll talk about why. It's actually appeared in the Bible. Phrase where God tells Moses to put a serpent upon the staff, probably this fiery serpent on the staff, probably in reference to this. And especially if you look at the historical or the Bible stories, they were in the region where Dracunculus is found, or can be found. Now, this parasite is one of the largest nematodes. The females can reach up to 80 centimeters in size. Pretty big for a nematode. Inside the humans, which humans are the host, most of the infections occur in the lower limbs, in the leg and the feet. This is also a parasite that has received a very concentrated effort to completely eradicate it. So in 1986, 3.5 million individuals were infected with dracunculus or exhibited symptoms of dracunculus. This parasite was considered endemic in 20 different countries. In 2004, we only had 16,000 cases, a little more than 16,000 cases. In 2019, latest information we have on the World Health Organization, the CDC's website, we only had 54 cases spanning 4 to 5 countries. Now, we put the range 4 to 5 countries because it's thought that that 5th country was actually represented an imported case. An individual was infected in a neighboring country, traveled to that 5th country, and then exhibited symptoms. So we'll talk about this eradication effort and how it was successful and why it might not be possible to completely eliminate this parasite. All right. So the life cycle. The life cycle has an intermediate host. We're going to expand our camera. It might be too hard. Dracunculus medinensis. Here we are. Covered. Oh, just off. Just off. All right, so our female adult is going to be found in skin lesions of its host. So skin lesions of its host. All right. Our worm is going to cause this lesion, it's going to rupture, and then the body wall of the worm ruptures as well. Our body wall ruptures, and that allows the J1s to enter the environment. All right? Now, as we're going to see, it really needs water. And the life cycle depends on water. So the body wall is going to rupture in this region, allowing the uterus to also rupture, and J1s start to release, and then the cool water will cause muscle contractions. That start to force the J1s out of the uterus. And as the uterus empties, additional filled uterus starts to take its place, aided by the cool water stimulated muscle contractions. All right, so our J1s are going to be released into the water, and then the J1s are going to be consumed by aquatic copepods. All right, now, these J1s don't have a very long time to get to these copepods. These are very short-lived. All right, they're effective for about 3 days, but they're going to live for about 4 to 7. So I know we talked about it early on in that first week about this idea where you need energy. The larval stages need energy to establish an infection. This is kind of an example, right? You had a minimum level of energy that was needed. So when they get into the host, they can then migrate out of the gut and develop, at least start to develop, to our juvenile stages. If that 3rd day passes,
then there's not enough extra energy available, so even if they are consumed, they're not going to infect that copepod. So inside our copepod, we get consumed. We get consumed by our copepod. The J1 is going to burrow out of the gut, get into the hemocoel, where our juvenile is going to molt to the J2, it's going to molt to the J3 stage. Now this is temperature dependent. Right, how quickly this happens is temperature dependent. At 25 degrees Celsius, it takes about 12 to 14 days, so about 2 weeks. About 2 weeks to develop to the J3. Warmer waters, they're going to develop faster. Cooler waters, it'll take a lot longer. But we need to get to this J3 stage because that is the stage that is infective to our next host. All right, so our infected copepod is going to be consumed. So here we are in water. There's our human. Human's going to accidentally consume that copepod. So once it consumes the copepod, our J3 is going to get released from our copepod and will be in the gut. At this point, the J3 then is going to penetrate out of the gut into the abdominal muscles. So abdominal muscles, and then they burrow through those abdominal muscles to get to the subcutaneous tissue. And it's going to remain in the connective tissues. The connective tissue of the skin. So, and we specify this because you can always think about, well, we're going to burrow out of the gut, get to the circulatory system, and then go like lungs, heart to lungs, and then get to like the blood capillaries and escape from there. All right, that's one route, but that's not the route that these guys take. They burrow out of the gut, they go through the abdominal muscles to get to this subcutaneous connective tissue, and then once they get here, they migrate to the subcutaneous tissue of the axillary, or the armpit, and inguinal regions, or the groin. This is all sub-Q tissue still, right? But they're going to these sites, right? Axillary area, so the armpit region or the groin region. And at this point now, our worm's going to start maturing. So it takes about 20 days in order for our worm to mature and molt to the J4. All right? And then it takes another, I don't know, a little more than a month, 43 days, to molt into our adults. About 43 days to get to our adults. 20 days, we get to here, 43 days, we are now an adult. In the subcutaneous tissue, in either the axillary or inguinal region, wherever the worm goes. We're still in those regions. Now, the worms, once we get to the adult, they're going to mate. Males are going to die at 3 to 7 months. Males are going to die at 3 to 7 months. So they're going to mate, they're going to try to mate, they're going to live for 3 to 7 months, and then they're going to die. And when they die, they basically become encysted and degenerate. The host immune system kicks in. Females, on the other hand, are going to grow, and they're going to start their embryo production. No, I didn't say egg production because we're going to release our J1s. The first life cycle. Right. So at about 3 months post-infection, our females have been fertilized. And now they've started embryogenesis to produce all of these embryos. At about 8 to 10 months post-infection, our female worms will now start to migrate. Only the females. Only the females migrate because the males die. Females will migrate at 8 to 10 months post-infection. Where are they migrating to? They are migrating to the surface of the skin. So they're in subcutaneous region. All right? They're already in that subcutaneous tissue. What they're going to do is migrate closer to the surface of the skin. And oftentimes they're going to migrate to the extremities, typically the lower limbs, so feet and the lower legs. Once there, that female is going to start to form a blister underneath that skin. Why? It gets there and it's already starting to break down. The body wall is already starting to loosen up, forming this intense immune reaction. So just think about it. Blisters, if you've had it on your fingers or hands, or blisters on your feet, that's a type of reaction. You get that liquid, that fluid in there as kind of a protectant. Well, the immune response is kicking in, doing the same thing, and you get this blister that forms that can ultimately open up into a lesion. All right? And this is going to happen 10 to 14 months post-infection. So you accidentally consumed a copepod. You're not going to get this blister forming for a year. That's on average a year. Now the blister and the lesions is tied to the pathology, and this might be something that increases the chance of successful transmission. Why is that?
Might first.
What's that?
I was like blisters might first.
They do. That's what gives our lesions. But what do blisters feel like? Yeah, you've had it when you get blisters on the heel, hands. Don't they feel like a burning sensation? You get a burning sensation. What do you try to do? Put it in cold water. All right. Definitely. So, yeah, this is the life cycle, and it seems like the pathology at least helps this parasite get to the water where it needs to be because it has to get into a copepod host. Questions? All right, so other things about this life cycle.
So I know like the way that the copepods get into humans is like to consume them, but like how are the copepods getting consumed by humans to result in us getting infected?
How did humans
Yeah.
accidentally consume a copepod?
Yeah.
Number one, how big are the copepods? Tiny. Where do they live?
Consuming water.
In the water.
Is it like
What do humans need to live?
Water.
How do we drink? How do we get our water?
Tap.
Tap water.
If you go camping in the middle of nowhere, how do you get your water?
In the river.
From a river. What do we do with that river water?
supposed to boil it.
Boil it or filter it. Right? Hit it with iodine. How many people actually do that?
I don't know.
More than you think. I have. I've done a lake up in Canada. Drank right out of the water. Didn't have my filter with me. So what did I do? I took my bottle, stuck it down up the length of the arm, and then I took the lid off. With the idea that if anything that's floating on the surface, I don't want that. Did I get sick? No, I didn't. Not this time, anyways. We'll talk about some other stuff that can happen. But yeah, you got to remember, where is this parasite? It is Africa, Middle East, all right, equatorial regions, and this is really, you can say, a third world country problem. All right, because they don't have the supplies, they don't have sanitation, they don't have the water treatment facilities. So we'll talk about it. We'll talk about that. All right, so with this life cycle, we talk about vulva in nematodes. We can see some of those in our whipworms, especially if they are in the correct orientation. All right, well, in this worm, the vulva actually atrophies. All right, it basically decomposes and seals up so that it is non-functional in the adults. Now, is that the reason why the body wall ruptures, or is this a situation where the body wall ruptures? That's became a more efficient way to get the J1s out, and thus then you didn't really have a need or a purpose for that vulva. All right? Did the chicken come before the egg? Type of problem. But that's, if you're wondering, well, why aren't the J1s like released through the vulva just like in trichinella, for example? This is why it's non-functional in the adults. Number 2, we need a copepod intermediate host. That is required. All right, humans can't get infected until that J1 gets into a copepod and develops to the J3. And you actually need the correct copepod. So there are different types of copepods. You need a cyclopoid copepod. Right, cyclopoid copepod. And then this J1, or the adult worm, it dies. All right, its body wall ruptures. The uterus is going to be filling in. Is going to be moving and filling in spots, and once all the J1s are out, or when almost all the J1s are out, that worm will die. And then once it dies, you're going to have to remove that worm because your body's going to still be fighting this infection. How do you remove it? You wrap it on a stick and you remove several centimeters a day. You have to do it very slowly. If you do it too quickly, you will break the worm, leaving a piece under the skin, and you will get a pretty strong inflammatory response at that location. All right? This is the idea of Eradication of the fiery serpent. Get it on a stick, wrap it up. Now, this is a matchstick, but any stick can do. And you can see, these are pretty large worms. It's in subcutaneous tissue. You have to slowly wrap it out and slowly remove it. Now, you could probably remove it much more quickly by going surgery and actually cutting it out, but this way works. It'll take several weeks to get the entire worm out, but it's entirely possible to do that. All right, pathology. So if you get this, it's called dracunculiasis. All right, it's usually non-fatal. Usually non-fatal. But it does cause some pain and could be some anguish knowing that you're infected with the parasite. So what are some of the symptoms? What are some of the causes of the symptoms? Well, number 1 is that migrating female. All right, so once the female starts to migrate back to the surface, all right, we're going to stimulate an inflammatory response. And types of responses that you'll see would be a rash. You could experience nausea, diarrhea, dizziness, or all of those kind of tied to an inflammatory response. All right, you can also have localized edema, so localized swelling due to the immune response. And that's partly, or probably mostly due to her waste products. So she's excreting it, then our body's fighting it. Once we get to the surface, then you're going to get a very painful blister. And it happens about a month after that female reaches the surface. That blister is going to be itchy, and you will feel an intense burning sensation. And it's been described as being intense burning sensation. All right? That kind of will lead you to scratch. It'll probably lead you to try to get some cool water on it. Eventually, that blister is going to rupture, and it's going to create a lesion. So in this image, we have our blister that's formed. All right? That's our blister. Here's a lesion. All right, it's an open wound. So you're going to have this lesion that forms when the blister bursts. Now, that lesion is going to actually heal pretty rapidly and with minimal scarring if secondary complications do not occur. Most likely complication that occurs is a bacterial infection. Maybe not here in the United States if we had dracunculiasis here, right? Because we've got proper medical care, but again, we're looking at third world nations. We're looking at countries that have very little technology, little medical help, or they're in countries where medical help is hard to get to because of the warlords and warring factions. They're capturing everything for themselves. All right, these bacterial infections could be painful. So not only did you have this intense burning sensation in this blister, but now you have to deal with a bacterial infection, which now can be treated with antibiotics. If, by chance, that migrating worm fails to reach the surface and then dies, our body tends to take care of it. So it'll typically encapsulate and calcify the worms. But you can also have granuloma formation, which causes some necrosis, leading to abscesses in the tissue itself. Yeah, in subcutaneous tissue, you can get to some of these things. The pathology, how significant, and the specific types of pathology really depends on the location. Where did those migrating females go before they died? All right. A common symptom is actual arthritis. So these worms migrated and ended up dying right near the joints. And once they became calcified, now they started hindering the movement of the joints, which is your arthritis, basically. It hinders their movement. The arthritis is common. And that's as a result of these migrating worms that failed to actually reach the surface. Ready? Eradication efforts have focused on life cycle disruption. So as we look at our life cycles, all right, our skin, that skin of the host must contact the water. Those J1s are going to desiccate if they don't get out there, if they don't get into the water. All right, so we have to have humans living or with access to a body of water. That's going to be a hard thing to control. If you're trying to disrupt the life cycle, it's going to be hard to keep humans away from it. I mean, again, we're looking at, in most of these areas, we are dependent on that water. We're dependent on drinking it. We're oftentimes dependent on the organisms that are in that water. So, telling humans, hey, you can't go into that water is like telling my kids, hey, you can't go swimming this summer even though the pool looks great. And it's just not going to happen. It's not going to happen. Second thing of this is that water must contain the correct species of copepod. So some people would say, well, let's just go out there and kill all the copepods, so that way the water remains so humans can use it, but now we don't have to worry about the copepod. However, if you're going to try to kill off the copepod, the chemicals that are used, that they can use, tends to eliminate most, if not all, of the other invertebrates. And those invertebrates are an important food source for larger organisms in that aquatic system. So you go out there and you try to treat it to kill the copepods, chances are you're going to cause that entire ecosystem to crash. To me, that's an ethical problem. That's an ethical issue as long as there's another way. And that other way is to block that accidental consumption of the copepod. And this is where, this is the target, and that's filtering water. So you can say, well, can't we just go and give pills to everyone to kill off the worms? Yeah, you can do that, if you can get it delivered to them. If you have, I mean, it's cheap. If you can actually get those pills delivered to these villages, you can try that, but you still have to deal with the copepods in that water source and utilizing that water. But if you can encourage people to actually filter their water before use, then perhaps we can filter out the copepods and block that accidental consumption. So filtering water was very easy. One of the things that they started off was, hey, instead of just drinking immediately out of the water, take a bucket, pour the water through a t-shirt or nylon tights. Typically those holes, the weave, is tight enough to block any copepods from going through it. That works great. But if you're out there hunting and fishing, right, and you're thirsty, you might not have a bucket and a t-shirt or nylon stockings around with you. So you're going to still continue drinking it. So that's where Nixon? What other president's alive?
Carter.
Jimmy Carter. Man, I'm trying to go through. Jimmy Carter spearheaded this and managed to get corporations to produce these life straws. Now we've seen them. You can buy them for, hiking trips. All right? They produce these for dirt cheap. And they put rope on them and handed them out to everyone and said, if you're going to drink the water, use this. And that filter was sufficient to block out all of those copepods. This is the primary reason why we went from 3.5 million infected individuals in the mid-80s down to 54 cases in 2019. Now, back in 2015, 2016, they actually declared Dracunculus medinensis to be eradicated from this earth. They declared it. And then it popped up, they kept seeing it. Uh-oh, what's going on here? Maybe they're saying Carter wasn't using his straw and they put the blame on him. Use your straw. But everyone was getting these things, they were all carrying it around. And then what they discovered was that dogs were actually acting as a reservoir host. And this is a more recent development. Up to this time, it was thought that humans were the only known definitive host, of this parasite. And then once we failed to completely eradicate it, we're having, a handful, tens of infections throughout the globe cause people to say, okay, something's going on here. And they found some of the dogs were serving as reservoirs. They were getting Dracunculus, they were getting the blisters were rupturing, J1s were getting back into the water. Now, was this the same species or was this a completely different Dracunculus species? Genetic analysis suggests it is genetically identical. So those individuals that are going in dogs can also go in humans. And it's probably thought that this was a more recent adaptation. However, right, to our knowledge, it could have been all along. It just so happens that in these villages with that one water source, most of the people ended up being infected with it. So that you kind of miss the fact that dogs could also get it. So Dracunculus, we've done a pretty good job. They are still working on how to keep dogs out of the water.
How often do you have to replace the life straw filters?
Good question. I don't know. I don't know. Probably when they clog up, right? When they stop functioning. But yeah, they're cheap. They're super cheap. So yeah, Jimmy Carter really kind of spearheaded it. This is one of the great things, and again, we've come close. Any questions on Dracunculus? All right, so that's a tissue dweller. That was near the surface. Its strategy was to cause the blister to form and then skin ruptured so that the larval stages can get out. We're going to move to the filarial worms. All right, so these are members of the superfamily Filaroidea. All right, collectively, all of these members are called filarial worms. This will include two families. All right, the filarial worms are found in two different families. The Onchocercidae, which is what we're going to talk about, and the Filariidae. Now, in these worms, arthropods are going to serve as the intermediate host. And what we'll see is that we kind of have exceptions. That's what we're going to talk about. Because most members of these families are going to deposit J3s on the skin of the host, and then the arthropod insect's going to come along and pick them up. So as they feed on, let's say, some of the mucous membranes, feed on mucus, or feed, hop on the skin, they clean themselves and accidentally get infected and so forth. All right, so most of them deposit J3s on the skin. However, the ones that we're going to talk about, and some of these other species, they utilize microfilaria as their infective stage. These microfilaria are going to be ingested by our insect vectors. So the insect's going to come along and bite and feed on either the blood or the tissue fluid, and they're going to ingest these microfilaria. Now, what are microfilaria? They're juvenile stages, but they're not as differentiated as a J1. They're not as developed at. They're not developed enough to be considered a J1. So they've received their own term, microfilaria. In many cases, you'll see these referenced as advanced embryos, which probably, that's kind of sufficient. Right? But they're not quite a J1. They're not developed enough to be a J1. Now, these filarial worms can infect all classes of vertebrates except fish. It kind of makes sense because you don't have hematophagous insects feeding on fish. Members of this group also tend to rely on a symbiotic bacteria. That bacteria that infects them is called Wolbachia. I've heard some microbiologists call it Wolbachia. I don't know what Dr. Crable would call it, but I'm sure he is quite aware of these bacteria. These bacteria are symbiotic in a lot of arthropod insects. Right? And in this case, they are symbiotic in the worms themselves. This is a rickettsial bacteria. Right? It gets transferred from one worm to worm through transovarian transmission. So the mother worm, female worm, is going to pass these bacteria to their offspring, to the eggs. The males, basically, they're born and they're infected. They can't transmit it to anything else. These symbionts represent a possible treatment option because if you treat the host with antibiotics and the antibiotics get in and kill those Wolbachia bacteria, then you usually see reproduction impaired in those worms. Anything from significant reduction to egg production and embryogenesis to sterilization of the worms. So that's kind of the worms are utilizing the bacteria for some benefit that's likely related to reproduction. And our bacteria are benefiting by actually having a place to live and being transported between different hosts. All right, so the family that we focus on is the family Onchocercidae. Members of this family live in the tissues of amphibians, reptiles, birds, and mammals. So it's not just a mammal parasite. Vast majority of these are of no medical or economic importance. Doesn't bother us, doesn't harm us. But there are a couple that do impact us. Two in particular, Wuchereria bancrofti and Onchocerca volvulus, can cause some of the most gruesome and debilitating diseases in humans. And we're going to talk about both of these. Probably at least seen one of these symptoms and not even realize it. The last species, Filarial immitis, is a significant parasite of dogs. It's this parasite why our canine friends get antihelminthics, heartworm drugs, every month. All right. So we're going to talk about these three species, Wuchereria, Onchocerca, and Filarial. We're going to go over the life cycle. I do have images of the diet, like this is Wuchereria bancrofti. We don't have worms, we're not going to be able to see these, but I was looking for filler material. The slides weren't completely blank. But I do have images of pathology. All right. So we're going to start here, and we're going to start on Monday with Wuchereria. All right. Yes, have a good weekend.